Dear students, welcome. Today we are going to discuss about a special class of differential equations and what techniques to solve them. So the differential equation we are interested in today is a linear first order differential equations. So ODE, because it's ordinary differential equation. The whole course is about ODE mostly. So we have, how does a linear first order differential equation looks like? So you have y prime plus p of ty equals to g of t. Now, the highest order of the derivative is 1, and hence the first order. And you can see that this, if you bring it on one side and write it as f of t y prime equals to 0, you can see that it's going to be linear in y and y prime. So this is a first order linear differential equation. Now note that sometimes it can also be written in the following form: p of t y prime plus q of t y equals to g of t. And note that these two, this 1 and 2, are equivalent if p of t is not 0, right? If p of t is not 0, you can divide throughout by p of t to on equation 2, and you get y prime plus q of t y divided by p of t equals to g of t divided by p of t. And now you can choose to call this guy as your p of t and this one as small g of t. Yeah, so these two are equivalent when p of t is non-zero, capital P of t is non-zero. Now, what is this method of integrating factors? So in this method, we are interested to find y prime plus p ty equals to g of t. So first order linear differential equation. And it involves basically multiplying it by a function throughout. Let's call that function as mu of t. So first we need to find what mu of t is and multiply it throughout. Now, after multiplying by mu of t, what happens is the left-hand side of this differential equation, after multiplying by mu of t, becomes a derivative of a product. Okay, so let's basically see this in details. So we have y prime plus p of t y equals to g of t. Now we are multiplying it by an unknown function. We need to find what that function is. Multiply both sides by mu of t. Yeah. So when we multiply both sides by mu of t, you have mu of t y prime plus mu of t p of t y equals to mu of t g of t. Okay. Now the idea is that this side should become a derivative of some product of two functions. Okay. So we want it to become, so you can see that this is going to be mu of t y of t, right? Because if you basically take a derivative of this, what do you get here? You get mu prime t y of t plus mu of t times y prime of t. So now if you compare these two, so if this side was supposed to look like d by dt of mu of t y of t, what should have happened? So this part is equal to this part, and that's fine. But these two should have been also equal, right? So this means what should have happened is we should, mu of t times p of t should have been mu prime t. Yeah. So this would mean, so let's assume that mu of t is greater than 0. We'll show that later. Why is that the case? We'll see later when we are doing Abel's theorem or Abel's lemma, whatever you call it. So assume we'll see later. We see later using Tabel's theorem. Why is that the case? What do we get is mu prime divided by mu equals to P of t. But this implies what? This is derivative of what? This is d by dt of ln of mu of t, right? You can recognize that. Yeah. So we get d by dt of ln of this is P of t, right? So integrating on both sides, if you integrate on both sides, integrating on both sides of this, we get ln of mu of t equals to what? Integral of P of t. So I'll write it as integration of P of s ds t. This simply means integrate and put integrate P of s ds and then put t plus c. Now since c is arbitrary, corresponding to every c you will find an integrating factor. So we'll choose a c with c equals to 0. That will simplify the whole thing, right? So now if you simplify this, you get mu of t is e to the power P of s ds. Okay, or it can also be written as exponential of what? T P of s ds, where exponential of x is same as e to the power x. Yeah. Now this notation should not be confusing for you. Why? Because let me give you an example. What does it really means? It means that suppose your P of t is 2t, then integral P of s ds, P of s ds to t is simply integration of 2s ds. Now instead of t, I have s ds, and then I'm substituting, after integral, I'll substitute t. So when I integrate this, I get s square, and then I'm instead of t, I'm going to write what? I'm going to write t square. Okay, this is what it means. If you don't like it, you can simply write, if you don't like this, you can simply write as exponential of integration of P of t dt. Yeah, that's fine as well. Okay, all right. So now, so that is the story. So this is your mu of t. So your mu of t is what? Yeah, so, okay. So now let's see. Well, this is your function you multiply on both sides, and this is what is the integrating factor. Now, once you do that, once the integrating factor is done, now you see how do we solve this differential equation. So here, if you go back here, you will see that on this side, you will have, let me write it with a different pen so that's visible. So on one side, we have d by dt of mu of t p of t equals to mu of t g of t. Now, if you integrate this on both sides, you will get mu of t p of t equals to what? Integral of mu of s g of s t plus a constant c. Therefore, you will get, sorry, this was not mu of t p of t, it was mu of t y of t, my bad. So this should have been y of t. We are solving for y of t, right? So y of t, so we have y of t equals to this, or therefore y of t is 1 by mu t in t mu s gs plus c. Okay, where c here is the arbitrary, so c is arbitrary constant. So this method of solving differential equation is called method of integrating factors. And note that it is only applicable to linear first order differential equation. So let's repeat it. So we have y prime plus p of t, y equals to g of t. So first you need to write down the equation in the standard form. This is the standard form of the differential equation. Then you compute the integrating factor, mu of t. And then once you do that, you can write down the solution directly. Mu of t is 1 by mu t, mu s, gs, ds plus c. Let's look at an example here. So first of all, first thing, to write down this equation in standard form. Well, it is already in the standard form. So 1, already in the standard form, right? In standard form. Now I need to compute integrating factor. So first I need to see what are p of t, and so p of t is minus 2. What is my g of t? Yeah, I'm writing this in the standard notation. My g of t is t square e to the power 2t. Then the next thing is I want to compute the integrating factor. So calculate the integrating factor. So what is my integrating factor? My integrating factor is mu of t is integral of exponential of integral of p of s ds t, which is going to be exponential of integral t of minus 2 ds, which is going to be, what is integration of minus 2 is minus 2s, right? Because we are integrating with respect to s. So it's minus 2s, but we have to put t instead. So we get exponentiation of minus 2t, which can be written as e to the power minus 2t. Yeah. Note, you could have also written directly this thing as mu of t is e to the power integration of pt dt. Then we get this is going to be integration of minus 2 dt, which is going to be integration of minus 2t. And no plus c because, well, we are choosing the one. So there are so many integrating factors. We are choosing the one which is simplest. Okay. So now we can apply the formula. So what is the formula? Formula is 1 by mu t integral of this p, sorry, mu s gs ds plus c. So this is going to be 1 by e to the minus 2t integration of e to the power, what is mu s? Mu s is going to be e to the power minus 2s, right? Wherever there is t, you will write s times s square times e to the power 2s, because this is what gs is, right? Gs is going to be s square e to the power 2s ds plus a constant c. Now if you simplify this, these guys will neutralize each other, and you'll be left with integration of s square, which is s cubed by 3. So this is going to be 1 by e to the power minus 2t times s cubed by 3 plus c. So this is your function. This is your solution y of t. And then, of course, after you integrate, you have to put t inside. So this should have been t cubed by 3. So this is your solution. Yeah. Then fourth, you should check your solution. You can check your solution. If you take the derivative of, you will see that if you take the derivative, if you put this in this differential equation, it will indeed satisfy. Now, note that rather than remembering the formula, it is sometimes simpler to follow the derivation. What do you mean by derivation? So, well, you know that mu of t we have computed earlier. It's e to the power minus 2t. That we have done already. So we multiply throughout the differential equation by mu of t. So we get what? Multiply by mu t on both sides. So if I take the original differential equation, which is here, and I multiply both sides by mu of t, what do I get? I get e to the power minus 2t times y prime minus 2y e to the power minus 2t equals to t square. And observe that this is basically derivative of what? This is derivative of y e to the power minus 2t equals to t square. So taking antiderivative on both sides, this gives me y e to the power minus 2t equals to antiderivative of this is t cubed by 3 plus c. And this implies y, which is a function of t. So y of t equals to e to the power 2t t cubed by 3 plus c. Which are these two are exactly the same, right? I mean, you can take 1 by e to the power 2t minus 2t as e to the power 2t. So you can see the direction field and integration curves. If you run this, it's a GeoGebra file. You should run and see how it looks like. So let's go through another problem. We have y prime by t plus y equals to 2 by t. Okay. So first of all, this is not in standard form. Why? What is the standard form? The standard form is y prime plus p of ty equals to g of t. So let's multiply. So we should multiply this throughout by what? T. Multiply throughout by t. So this differential equation turns out to be y prime plus ty equals to 2. It is still linear first order, right? So we can use the method of integrating factor. So what is my p of t? P of t is going to be t, and g of t is going to be 2. Now, what is my mu of t? The integrating factor. Mu of t is going to be e to the power integration of pt dt. Now note that I'm using a different notation now. This is going to be integration of e to the power t dt, which is going to be e to the power t square by 2. Yeah, generally you have to add plus c, and that's why I wrote earlier sds and t on the top, so that you don't have to use the that was a different notation, which means that you don't have to add any constant, but this is fine. Okay, so this is my mu of t. Now what is my formula? My formula is either I multiply throughout by integrating factor, or I can use the formula. So let's see. Let's use well, we can multiply throughout by the integrating factor. Let's use that. So multiply throughout. Multiply the equation 2 by mu of t. So we get e to the power t square by 2 times y prime plus e to the power t square by 2 times dy equals to 2 e to the power t square by 2. Now, this can be written as what? Derivative of d by dt of e to the power t square by 2 times y. Yeah. If you apply the product rule, this is exactly what you get, right? And that should not a coincidence. This is how the mu of t, if you look at the derivation of mu of t, this is how it is created. So we get on the other side 2 e to the power t square by 2. So if you take antiderivative on both sides, you'll get e to the power t square by 2 y equals to integration of 2 e to the power t square by 2 dt plus a constant c, or we get y of t equals to e to the power, divide both sides by this guy, so t square by minus e to the power minus t square by 2 integral 2 e to the power t square by 2 dt plus c. Now we would like to integrate this, but this function has cannot be integrated using elementary antiderivative. Elementary antiderivatives, right? Because it has no elementary antiderivative. So in this case, this is the solution. Now, if you really want to basically have some idea about how the solution look like, you can have a power series expansion of e to the power t square by 2 to look at the solution and integrate term by term. And there are some other techniques, all right? So this is it for section 2.1. Let me brief again. What did we do? We solved a first order linear differential equation by method of integrating factors. So that's about it, folks.